Good evening, friends. So I've had some difficulty getting my voice to sound normal, or at least more normal than usual. Tonight, we're going to talk about geometric sequences. Geometric sequences. Okay, so geometric sequences are unlike arithmetic sequences in that rather than a common difference between the terms, there is a common ratio between the terms. I'll write that down. Unlike arithmetic sequences, where there is a common difference, d, between terms in a geometric sequence, there is a common ratio, r. So what does that mean? So let me show you a couple of examples. So our first example, let's do 10, 5, 5 halves, 5 fourths, etc. So what you'll notice is that if you divide 10 by 5, you get 2. If you divide 5 by 5 halves, you get 2. If you divide 5 halves by 5 fourths, you get 2. Another way of looking at it is, if you multiply 10 by 1/2, you get 5. If you multiply 5 by 1/2, you get 5 halves. If you multiply 5 halves by 5 fourths, if you multiply 5 halves by 1/2, you get 5 fourths. So our common ratio, the way to get from one term to the next term, is to multiply by 1/2. Okay? So let's see if you get this general idea. I'm going to write down another example. Okay? And let's see if you can figure out what the common ratio will be. You can pause the video. Okay, and the common ratio here is 3. You multiply the first term by 3 to get the next term, 3. 3 times 3 is 9. 3 times 9 is 27. Da, 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 da. Okay, so the last one is a little trickier. Let's do this. All right, -1 it is. Outstanding. Okay, so let's talk about how you would write rules for these things. Remember, there is a recursive rule that we can use to write pretty much any pattern, and that just relies on previous term. Okay, remember a sub n minus 1 is previous term times the ratio equals a sub n. Okay, so a recursive rule just says take the previous term and multiply it by our common ratio, and you get the term. So a sub n, this is the one before it, and that's how you get that term. That makes sense, right? The explicit rule is more powerful, and it allows you to write a rule that does not depend on finding each consecutive term. So there are actually two ways to get the explicit rule. You can write a sub n equals a sub 1 times r to the n minus 1, or you could write a sub n equals a sub 0 r to the n. Okay? Now this may frighten you that we could write the explicit rule in two ways, but if you think about it, a sub 0, really we're talking about a y-intercept. A sub 0 is a y-intercept, just like it was with an arithmetic sequence. And so this right here, you should recognize this function. What kind of function is this? That's right, it's an exponential function. If we graphed it, we would get like an exponential growth function or an exponential decay function. And in this case, if we took the rate to the position, in order to get our y-intercept, we have to go back to the 0th term, not the first term. If over here we're starting with our first term, we basically have to shift our graph to the right to make them line up. So if we start with a sub 1, we're shifting our graph to the right 1. If we start with a sub 0, we don't have to shift our graph at all, and we get our rule. So there you have your two types of rules here. So we should try applying these rules to a couple of examples. Okay, so let's try this 10, 5, 5 halves, 5 fourths example. Okay, so if I'm going to write the recursive rule is just so simple because it's previous term times r. So do we remember what the r was here? To get from this term to that term, it is 1/2. Okay, so that is our recursive rule. Boom, done. Okay, our explicit rule is going to take a little more work. So just to get ready here, let's figure out what a sub 1 is. A sub 1 is, that's correct, it's 10. It's the first term in the series. A sub 0, so here's a sub 2, here's a sub 1. A sub 0 is going to be going in the other direction. So if we're dividing by 2 to get to there, yes, we would multiply to get to there. So a sub 0 would be 20. So for this rule, this 1 here tells us that we're going to have to shift. So we have a sub n equals 10 times, oh, what did we say r was? R equals 1/2, right? Okay, so 10 times 1/2 to the n minus 1. That's a sub 1, so we have to shift this one over so that we can line up our graph properly. This one here, a sub 1, equals 20 times 1/2 to the n. Now, if you're worried about confusing these formulas, and I really don't want you to think about memorizing these formulas, I want you to understand why they work. You know, we're talking about the first term times the rate, the common ratio, and then raised to a power. So if you forget which way it works, what you can do is, let's plug in n equals 3. This is the third term in the sequence, right? So we're going to plug in n equals 3, and we hope that we get out 5/2. So let's try that. So we do 10 times 1/2 to the 3 minus 1. So that's 10 times 1/2 squared, which is 10 times 1/4. 10 times 1/4 is 10/4, or 5 halves. Did we do it? We did do it. Okay, let's try the other one just to make sure. So we'll plug in 3 here, so we get 20 times 1/2 cubed, and that's 20 times 1/8, which is 20/8, which is 10/4, which is 5/2. Yay, we did it. This is great. Okay, so as a little bit of practice, let's see if you can identify, or if you can differentiate between an arithmetic function, a geometric function, and one that's not either of those types of functions, or in other words, sequences. Okay, so I'm going to write these down, and I want you to think about what type of sequence they are if you can categorize it by name, and you can use neither if you don't have a name for it. Okay, so while I was writing, I'm sure you were thinking about it. If you want to pause the tape, you can. Okay, if you want to pause the video, you can. But so for this one up here, example 1, do we have a common ratio? We appear to have a common difference, correct? It's 3, 3, 3. So there is a word for that one. Yes, it is an arithmetic. The lights just went out on me. That's arithmetic. Wow, it really went out. Hope you can still see me and hear me. The second one, let's see, 64 to 32. Well, we could subtract 32, but here we'd be subtracting 16, and here we'd be subtracting 8. I don't think that's it. Let's see if it's geometric. So 64 divided by 32 is 2, and 32 divided by 16 is 2, and 16 divided by 8 is 2. Okay, so guess what? That, my friend, is geometric. Just to go back to that whole graph thing, this would be like an exponential decay, right? Like that. Just to throw that in there. And then this one, let's see, if I don't know what multiply by 7/5. 7/5. No, that doesn't get us to 10. So, how about let's find the differences. So that's a difference of 2, that's a difference of 3, that's a difference of 4. Ooh, we saw those, right? So that's not linear, it's not arithmetic, it is quadratic, correct. So we could call that quadratic. This would create a parabola, okay? It's not arithmetic, okay? And just one little more piece of review, if you want to have fun here, you could determine what the explicit rules are for these. I know you can't do this one, and I'm sorry, we're not going to talk about that in this video, but maybe later. But the arithmetic, I'll pause the video, and you try to find the explicit rule for that one and the explicit rule for that one, and I'll do it at the same time. We'll race, see who finishes first, and then you can check your work. Okay, pretty sure I won. So here is our explicit rule for our arithmetic. Remember, we find the common difference. That's our slope. And then we go back and find our a sub 0 term, which is subtract 3 from that. And so 1 minus 3 is -2. And for our geometric, we can either use a sub 1 and to the n minus 1, or we can use a sub 0, which if we're dividing going this way, we will multiply by 2 going this way. We got 128 times 1/2 to the n. Now you will go on and do your little check on your quiz thing to make sure that you have understood what I just talked about.